Assalamualaikum warahmatullahi wabarakatuh and hi all. We are still in chapter 2 solid gas interface and this is video part 5. In this video, we are going to discuss another subtopic in this chapter, BEP model. A quick recall here, absorption isotherm is the variation of amount of gas absorbed as a function of pressure at a constant temperature. So as the pressure increase, the amount of gas absorbed on a surface will be increased. Okay, at monolayer absorption, the isotherm can be described using Lamoille model as what we have discussed in the previous video. Okay, at multi-layer absorption, the isotherm can be described using BEP model, which we are going to discuss today. BEP model is actually referred to Brunner, Amit and Taylor, which is the name after the scientists who first developed the model. So they are Stephen Brunner, Paul Hugh Amit and Edward Taylor. BEP model is an extension of the Lamoille model, where here the model consider multi-layer absorption instead of monolayer absorption as assumed by Lamoille isotherm. This figure shows multi-layer absorption on a solid surface. The absorption will continue until the gas can no longer absorb on the surface and capillary condensation start to begin. Okay, assumptions of the BEP model. Okay, the same as Lamoille, BEP have several assumptions. First, the same assumption as that of Lamoille, but now BEP allow multi-layer absorption. Second, all the surface side are energetically identical. Okay, third, the heat of absorption, delta H absorption, for the first layer is determined by the interaction between the adsorbate and the absorbent. Okay, for the following layers, it is depends on the interaction between adsorbate or heat of vaporization. Okay, then there is no lateral interaction among the absorbed molecule. That means absorption are localized. And the final assumption is at the saturation pressure P0, the number of layers are infinite. BEP equation. The BEP equation are derived based on the kinetics and thermodynamics of the absorption process. The derivation is a bit complicated. In our scope, we will not discuss in detail how the equation is derived. Here, we only apply the linear form of the BEP equation, which is P over N times P0 minus P equals to 1 over NMC plus C minus 1 over NM times C times P over P0, where P is the equilibrium pressure of the gas, P0 is saturation pressure, N is quantity of gas absorbed at different pressure, and M is monolayer capacity, which is the quantity of gas absorbed at monolayer absorption, and C is BEP constant, which is related to the absorption energy at the monolayer. And then the value of C can be used to determine the adsorbate interaction energy. In detail, C equals to exponential of H1 minus HL over RT, where H1 is the absorption heat of the first layer and HL is the liquefaction heat. Okay, the C value can give indication of the affinity of the adsorbed molecule for the solid. Maksudnya, from the C value, we can determine whether the gas molecule like to be absorbed on solid surface or to be in the bulk phase. Okay, if H1 is larger than HL, C value is high. That means there are strong interaction between the adsorbate and adsorbent. In other hand, if H1 is smaller than HL, C value is low, which indicate that the adsorbate-adsorbent interaction is weak. This figure shows a plot of gas absorbed versus relative pressure for different C values. Curve A is where the C values is the smallest. Curve dia bentuk lengkung ke bawah. So next time, if we found this isoterm yang at low relative pressure, bentuk dia macam ni, so we know that there is a weak interaction between the adsorbent and the absorbent. Okay, then when increase the C value up to 10,000, the curve shows a rounded knee as shown by D here. So this isotherm indicate that the adsorbate has a high affinity towards the adsorbent. Okay, other point to take note, the high C values also indicate the presence of microporosity in the solid sample. So this topic we will discuss further next time. That's all. I hope you learn something from this video. And to enhance your understanding, here I provide several questions related to this topic. Okay, please answer all the questions. Okay, many thanks and bye-bye.